Hi, kinematics exercise 2. I'm taking some questions from this exercise. Right now, question number 9, in which a ball is released from top of a tower of height h, which takes t time to reach the ground. What is its position at t by 3 second? And the question says from the ground, right? So this is a tower of height h, and a ball is released. Obviously, its initial velocity is 0. So the relation is h equals to half gt square if t is where t is the time taken by it. Using the formula s equals to ut plus half at square. Now it also says in time t by 3, its position from top is given as x. So what is the relation of x and t by 3? Using the same formula s equals to ut plus half at square, you will write x equals to half g into t square upon 9. I put t by 3 in place of t, right? Further, x equals to h upon 9 we can write it because this complete portion is basically h, right? Now the question is, how much is the height from the ground? So h dash will be h minus x simply, and after solving this you will get h at upon 9. Answer is C. So next one is question number 13. There's a relation of time and position where a and b are positive constant, and we have to find the acceleration. And you also see the options all are given in terms of velocity. There is no time or there is no x, right? Obviously, for acceleration, we have to differentiate this equation 2 times. Okay. So let us begin with, given is your t equals to ax square plus bx. Now first time differentiation with respect to time. Differentiate with respect to time. So time differentiation will give you 1. X square differentiation will give you 2x into dx upon dt, which is v. b into differentiation of x will give you dx upon dt with respect to time, which can further be written as 2axv plus b into v. Take v common, so 2ax plus b, and v is here. So observing that we will be using v in future in the coming steps. So v equals to, we can write 1 upon 2ax plus b, right? Also, we are going for the next time differentiation. So using the formula 1 equals to 2ax plus b into v, will be differentiating it using product rule. So differentiation of 1 is 0. V is kept, and differentiation of 2ax will give you 2av, x ka differentiation dv upon dt, and 0 for differentiation of b as constant. Then plus from the product rule, 2ax plus b kept undifferentiated, then velocity will be differentiated and will get acceleration a dv upon dt. But already we are using a as constant now, so we will use some other terms for acceleration. Let's say f. So f is the acceleration in this case. When I rearrange this, we get minus 2av square whole divided by 2ax upon plus b. Now because final answer is in v form, so see here 1 upon 2ax plus b is also v, so we can write it like this. This become cube because v square was already there, and 1 upon this term will become v also. So this is our answer. Answer is C. So next we have question number 14. A car is starting from rest, so u is given 0. Acceleration is f through a distance s. Okay, it continue with the speed constant speed for time t and deaccelerate at the rate of f by 2 to come to rest finally. The total distance traveled is given as 15f. Then which of the following relation is correct? Now we can go by the equation solving also. There are three different stages given in this: first acceleration, then constant speed, and then retardation again. But I will prefer to go by graph method for better understanding of the situation given. So if I draw the graph of time versus velocity, so in first t time, no, time is not given. In first part, let's say for time t, it has traveled a distance s with constant acceleration of f. Okay, so certainly it may have achieved some velocity v at the end of time t1. Now with this constant velocity, it goes for further time t, and then it retard with the acceleration of f by 2. Time is not given. Let's say t2 is the time. What is given is the total distance is 15s. Okay. So let us connect the variables, like what we have assumed unknown as t1 and t2, right, and v also, this v. Now in first section we can write area of vt curve gives you displacement or distance in this case because direction is not changing. So half into height into base is equals to s. Keep it as the equation number 1. Also the slope. Slope gives us the acceleration. So f equals to perpendicular upon base. Perpendicular is v and base is t1. So v upon t1, and from here we can get t1 equals to v upon f. Likewise in the third section, retardation is f by 2, which will be v upon t2. t2 time में retard होकर के 0 हो गया था, and from here t2 you will get 2v upon f. Now I can write the total time. So what we can use is total displacement or total distance. That distance equals to area on VT curve, right? Now it is given 15s and area is given in this figure as half into height into sum of parallel side, trapezium होने के वजह से. So half into height into sum of parallel side. So this is t plus denominator side, this one, which will be t plus t1 plus t2. Now we need to simplify it. Okay, so I have put over here t1 t2, right? So when you add t1 and t2, you will get 3v upon f, like this. Also from here, if I put this t1 in equation number 1, what we get is s equals to half v square upon f. Okay, so now you can substitute over here 15s equals to v into t plus 3v square upon 2f. Okay, now from here this is 3s vt plus 3s. Now keep this on this side, so it will become 12s equals to v into t. Now you see s is there, but v is not there in the option. So what we can do, we will have to replace this v. Again we will be using this formula. So v square equals to 2fs. So we'll put it here. So we need v square. So square both sides, 144s square equals to v square and t square. So 2fs into t square from there. Now 1s will get cancelled. So s is equals to 1 by 72 f into t square. This will be your final answer. C is the answer. So next is question number 16. A parachute after bailout falls 50 meters without friction. When parachute opens, it deaccelerates with 2 meter per second square. He reaches the ground with 3 meter per second. At what height did he build out? Right. So let's say from here it built, right, at t equals to 0, it will have some 0 velocity. Now it has fallen freely for 50 meter, and up to this point it may have gained, it will gain some time, some velocity, that is given as root under 2gh, right? If we use 9.8 here in place of g, so we get 2 into 9.8 into 50 root cover. On solving we get 980 root cover. Now at this place it will open the parachute, and after this it start retarding and will land the ground with some final velocity, let's call it v dash, equals to 3 meter per second. So at what height did he build out? So first we will find this x. Okay, so answer will be x plus 50. So how do we solve this x? So we know the initial velocity, we know the final velocity. So we'll be using v square equals to u square plus 2as for this section. Now v square is, so v is your 9, 3 square is 9, and then u square means 980 minus 2 into x. Solve this x. So this is 971 divided by 4, and it will come 2, 4, 3 approximately, right? This height will come. So bailout position will be 50 meter above this. So we'll have to add 50 in this. So we will get 293 meter. So the answer will be C. So in question number 17, x equals to 0 given at t equals to 0 starts moving along positive x-axis and velocity is varying like this. What is the displacement as a function of time? So simply you need to integrate it. X निकालने का है तो integrate करना है. So v equals to alpha root under x, right? dx upon dt equals to alpha root under x, x to the power minus 1 into dx equals to alpha dt, like this, and then go for the integration. This is from x1 to x2 and this is from 0 to t. Okay, position is also given, so we will take x1 as 0 and x2 as x. So when we integrate this, x to the power 1 by 2 and 2, this will come, and after putting limit also this will come, and here it is alpha into t. So x is basically proportional to t square in this case, right? A is the answer to this. In question number 20, given as a body starts, actually two bodies start from the same position, but one is moving with constant speed and other is accelerating with constant acceleration. At x equals to 0, t equals to 0, starts with a constant acceleration. At the same instant, another body passes x equals to 0 with constant speed. The position of first body is denoted by x1 and for the second body it is x2. Then which of the following is correctly representing x minus x1 minus x2 as a function of time? So this is basically relative position. x1 minus x2 is the relative position with respect to x2. Okay. So let us say this is x equals to 0 and t equals to 0. This is body 1, which is moving with constant acceleration and has initial velocity 0. This is body 2, which is moving with constant speed, let's say v, and its acceleration is 0. Obviously, body 2 has initial velocity, so body 2 will lead and body 1 will remain behind. Okay, so after some time, what will you see is the situation like this: 2 आगे है और 1 पीछे है. Now, if you take 2 as an observer, so you will see 1 on the back side, means on the left side. So I can say that x1 minus x2 is negative for this at this time. But because 1 is accelerating, a time will come when 1 will overtake 2. Let's say this is the position where 1 is overtaking 2. Now when this is happening, the value of x1 minus x2 will be 0. Now after this time, 1 will gain velocity more than that of 2. 2 has constant velocity. So what you will see is 2 is remaining behind and 1 is leading now. Now with respect to 2, if you see 1, it will be positive, means x1 minus x2 will become positive now, because 1 is on the right side of 2. So what we see, initially negative, then 0, and then positive. So which of this graph is representing this? And other thing is, body 1 is accelerating, so xt graph will be a parabolic in nature, right? First negative, then 0, it is 2. So in question number 22, a particle moves with a velocity where k is constant. The general equation of the path is. So you have to find the equation of path, and for that we know that we have to eliminate time to get the xy relation. So what we will do here is, from the given equation, what is the x-axis velocity given? So it is ky, right? This is dx upon dt, call it equation number 1. Similarly, see on the y component, so velocity on y-axis is kx, which is dy by dt, equation number 2. Now we can divide this equation because we don't want dt in the expression. So on dividing 1 by 2, we get dx upon dy equals to y upon x. Do cross multiplication, we get this expression. Now we are ready for integration over here. So we can put integration here like this. So x square plus c equals to y square, x square upon 2 and y square upon 2, right? This is the integration of this part. So we can simplify it as y square equals to x square plus some constant. ओके, यहाँ पे 2 से मल्टीप्लाई करेंगे तो यहाँ पे 2c आ जाएगा, बट 2c अगेन इज अ कांस्टेंट, सो वी कैन सिंपली ट्रीट इट like this, and therefore answer is D. Now in this question, an object is moving with the initial speed of 6.25 meter per second and deaccelerating at the rate of minus 2.5 v to the root cover v. Time taken for the object to come to rest. So final velocity of the object is 0 as it has to come to rest. So time taken is to find out, we need to integrate this equation from given initial velocity 6.25 to the final velocity 0. So given is dv upon dt equals to minus 2.5 root v. We will write it v to the power 1 by 2 into dv equals to minus 2.5 into dt by doing cross multiplication. Now you need to integrate it. Now in this integration, time will go from 0 to t and velocity will go from 6.25 to 0. What is the integration of x v to the power 1 by minus 1 by 2? So we have to do plus 1. So it will give you 1 by 2, right? Minus 1 by 2 plus 1, that will give you 1 by 2 divided by 1 by 2 and then limits. 6.25 से 0 तक इक्वल्स टू 2.5 इंटू टी. So after putting the limit, this is 2, upper limit minus 0 minus 6.25 whole to the power 1 by 2 equals to minus 2.5 into t. So minus minus will get cancelled. We get 2 into 2.5 as 2.5 into t, and t is equals to 2 seconds. So in 2 seconds it will come to rest. Is the answer. Now in question number 24, water fountain from the ground sprinkles water all around it. If the speed of water coming out of the fountain is v, so what is the total area around the fountain that it get wet, right? So angle of projection is not given, so we'll assume that the water coming out is all around and have the angle variation from 0 to 90 degree. Some of the waters are coming at 0 degree and some are also coming at 90 degree, and rest are all in between. So we'll focus on the maximum area covered. So any of the water splash will come out with 45 degree of projection, and therefore the range corresponding to this by the water will be u square upon g, means v square upon g. Now this range will become the radius, right? This is how the splash is moving all around. So this is your range. So what is the area? Area is pi into radius square, which is range over here, and therefore pi u to the power 4 upon g square. So A will be the answer. So in this question, given as a tower of height h, particle is thrown vertically upward with speed u, time taken by the particle to hit the ground is n times the time taken by it to reach the highest point of its path. So you have to relate h, u and n. So first you need to figure out this question, which is very much important. So if this is the h height of the tower and a particle is thrown vertically up with the speed u, so this becomes reference level, and the path of the particle is like this. It will go a little height and then it will return back. So this is the highest point where the velocity is 0. So if I name it A, B and C, so according to question, A to C means to when it hit the ground, if it is the time t and t1 is the time for reaching to the highest point, t1 is the time for the reaching to the highest point, then according to question, t time, which is the time taken to reach at C, is n times t1. Okay, so first write how much is t1. So we have direct formula using v equals to u plus at. We'll get t1 equals to u upon g, equation number 1. Now for A to C, this was from A to B. Now A to C के लिए total displacement होगा minus h, and we are using formula s equals to ut plus half at square. So it will be ut minus half gt square. You need to substitute the values from equation number 1 to simplify it, right? So what will become t? T will become nu upon g, which we have to write in put in equation number 2. So on substituting this time in equation number 2, we are getting like this: minus h equals to nu square upon g minus n square u square upon 2g, right? So we'll take the LCM, simplify, and minus sign will get cancelled. So we'll get 2gh equals to 2 will be here, u square is common, and n minus 2 will be there, right? So which option is matching? This is B. So in this question, two stones are thrown up simultaneously from the edge of a cliff 240 meter high with initial speed of 10 and 40 meter per second respectively. So the best representation of time variation of the relative position of second stone with respect to first one. First one means the one which is thrown with 10 meter per second, and the second which is thrown with the 40 meter per second. So this is a building. Take two stones 1 and 2. 2 is thrown up with 10 meter per second, and 1 is thrown with 10 meter per second, and 2 is thrown with 40 meter per second, right? So which one will take less time to reach at ground? Obviously one will take less time to reach at ground, and 2 will take more time to reach at ground, right? So we have to find in how much time the ball 1 will reach to the ground. That is one point. Now if that time is t, probably that time is 8 seconds. After solving that we can get it, right? So for any time less than that time means 8 seconds से पहले क्या होगा, दोनों ही बॉल एयर में रहेगा. When the both balls are in air, the relative acceleration is 0, and therefore that will be the case of uniform motion, right? And in that uniform motion, ball 2 is at higher speed comparing to ball 1, means that is 30 meter per second is the relative speed. So that will be the uniform motion, and accordingly the distance between them will be changing, right? If I write x2 minus x1, it will be 30 into t. So how this graph appears to be? This will be linear. Now after time 8 seconds, when the ball 1 has already reached on the ground, ball 2 is still in air, and therefore ball 2 will appear to be accelerated from ball 1, right? Because ball 1 is now at rest and there is no acceleration in ball 1. So ball 2 will have acceleration of g, and therefore the further graph will be means variation of the distance will be parabolic in now, right? Now according to that, which could be the possible answer? So we can outrightly reject D, because after 12 seconds will be the time for the second ball to reach, right? So C will also be rejected. D and C will be rejected, because on the second part of the motion it has to be parabolic, right? Now B and A, this could be the possible answer. Now which one we have to choose? First part is okay, which is linear, but second part we can see this is downside parabola and this is upside parabola, right? So what happened to the second ball when it is reaching down to the ground? Speed keep on increasing. Which of these two is going to represent that? The increasing speed in downward direction, that is given by graph A, right? And therefore A will be the answer to this question. Okay, in this question, object is dropped from a height h from the ground. Every time it hits the ground, it loses 50% of its kinetic energy. The distance covered as t tends to infinity is, right? So there are many bounces when a ball is dropped from a height h, right? So it is starting with velocity 0 and it will hit the ground with root under 2gh. This is the speed with which it will hit the ground. Now it will lose the kinetic energy by 50%. So see, kinetic energy is proportional to velocity square. Now this velocity square is proportional to h. So when it loses 50% of the kinetic energy, it will go up to a height h by 2, right? So second bounce means after first bounce, it will go to height h by 2, then it will return back to h by 2. This is your first bounce. Now in second bounce, it will lose further half of the kinetic energy remain. So it will go up to a height h by 4 only now. h/4 तक जाएगा एंड इस तरह से इसका मल्टीपल बाउंसिंग के बाद ये मोशन रुक जाएगा. सो डिस्टेंस s इक्वल्स टू फर्स्ट हाइट जो ये नीचे आने में कवर किया, देन h/2 प्लस h/2 फर्स्ट बाउंस का, देन सेकेंड बाउंस में h/4 ऊपर एंड देन h/4 नीचे आया, एंड दिस इज हाउ इट इज गोइंग ऑन. सो विल टेक इट अप टू इन्फिनिटी. Then h plus h, this is h/2 plus h/2, then this is h/2, then next will be h/4, right? I have added this h/4 plus h/4 is h/2. Next term will come h/8 plus h/8, that will give you h/4. Now because this is a sum of infinity, so we'll be using the formula s equals to a first term 1 upon 1 minus r. Okay, so h फर्स्ट h को छोड़ दो और यहाँ से gp कंसिडर करके हम लेंगे, तो पहला टर्म होगा h और इसका कॉमन रेशियो होगा जाएगा 1/2. सो दिस इज h by 1 upon 2, which is h plus 2h, and it will give you 3h, right? So its answer is 3h. Its option will be 1 and a, and we will make a correction over here, 3h. Now in this question, position of projectile launched from origin at t equals to 0. So it is 0, 0, okay? It is 0, 0 at t equals to 0, and r equals to 40 I plus 50 j meter at t equals to 2 seconds. So projectile was launched at angle theta with the horizontal. So what is that? So for theta you need to know initial velocity, because tan theta will be vy upon uy upon ux लिख लेंगे, ठीक है. So we need to know the initial velocity, right? Now on x axis it has covered 40 meter in 2 seconds. So x axis पे हम फॉर्मूला यूज करेंगे s equals to ux into t. So ux is coming as 40 divided by 2, that is 20 minus 20 by 2, that is 40 by 2, that is 20 meter per second. Likewise on y axis it has covered a distance of 50 meter in 2 seconds. So we'll use the formula s equals to ut plus half at square. Okay, s equals to ut plus half at square. Now what is u? So what is the displacement? It is 50. U means uy into 2 minus half g के जगह पे 10 लेने का into 10 into 2 square, ठीक है. So what does it comes after solving? So vy is coming 15 meter. Okay, so tan theta will be equals to vy upon vx, that is 15 upon 20, that is 3 upon 4. Sorry, this will be added up now. This will be added up. So this will become 70 by 2, 35. This will become 35. So this is 35. And now 7 by 4 will be the answer. So in this question, a person climbs up an escalator in 60 seconds. If standing up on the same, but escalator is running with constant velocity. He takes 40 seconds. How much time the person will take to walk up the moving accelerator, right? Escalator. So बेसिकली एस्केलेटर जब रुका रहेगा तो 60 सेकेंड में वो वॉक करके पहुंच जाएगा, ठीक है। और जब खुद वो खड़ा रहेगा केवल और एस्केलेटर मूव करेगा तो वो 40 सेकेंड में पहुंच जाएगा, ठीक है। अब दोनों अगर कंबाइन हो जाए तो फिर क्या होगा? सो लेट the distance to be covered with the escalator is d. So when the man is walking, what is the speed of man? Speed of man will be distance upon time he takes when the escalator is not moving. What is the speed of escalator? इस केस में man खड़ा रहेगा और escalator move कर रहा होगा, तो speed of escalator will be d upon 40. Now दोनों ही move करेगा तो कितना टाइम लगेगा? So time equals to the same distance d to be covered, right, with the speed of Vm plus Vs. Escalator plus man speed both are in the same direction. So d divided by d by 60 plus d by 40. D will get cancelled and after solving we'll get it like this. So it's coming 24 seconds. In question number 34, a bullet loses its one nth of its velocity passing through a plank. Number of such planks required to stop the bullet can be. See, when it passes through one of the plank like this, अगर इसका velocity v है तो दूसरे तरफ इसका velocity, it loses the velocity of 1/nth of its velocity, right? तो दूसरे तरफ जो इसका वेलोसिटी रह जाएगा वो रह जाएगा v इंटू 1 माइनस 1 अपॉन n, राइट। नाउ दिस plank offered some retardation in this bullet and the plank has some distance of x. So we can connect using the formula v square equals to u square plus 2as, right? So using the formula v square equals to u square plus 2as, we'll write final velocity is v 1 minus 1 upon n whole square. Initial velocity is v square minus 2a assume कर लिया and x, right? This will be your equation number 1. Now if we take some m planks, so for m planks, what will happen? How much distance to be covered? It will be m into x. This distance is to be covered and finally bullet has to stop. So we'll be using the same formula for this situation also. Initial velocity will be v, but final velocity will be taken 0. Okay, so using the same formula v square equals to 2as and same plank is used, so retardation offered to the bullet will be same. So it is 0 equals to v square minus 2a into mx. We have to find this m only, number of planks. Okay, so what we can do, we have to eliminate a and x, right? So you can write v square equals to 2a mx from equation number 2 and rearrange equation number 1. That will give you 2ax equals to v square minus v square n minus 1 upon n whole square, like this. This is equation number 1 after rearrangement. If we divide them, equation 1 और equation 2 को अगर आप divide करोगे तो यहाँ से a and x cancel out हो जाएगा with 2, right? So what we are writing over here, we will divide 2 by 1. So it will give me m equals to, in numerator it will be v square, in denominator it will be v square minus v square n minus 1 whole square divided by n square. So v square get cancelled, n square will go in the numerator. So this will be n square, v square will get cancelled. In denominator we will be left with n into n minus 1 whole square, n square minus this. You can take it on a square minus b square, from where you can get it n square and 2n minus 1 and 1, right? So yeah, this is the answer. So answer will be C. So in this question, which graph correspond to an object moving with negative acceleration and positive velocity, right? Velocity is positive and acceleration is negative. Now in option A, what we see, velocity is negative initially, acceleration is negative initially, but that acceleration become positive after some time, right? So we have to talk only about negative acceleration, so this will not be the case. Now VT curve पे फिर से slope बनाएंगे B option में. So we are observing there is positive slope, means positive acceleration. So again B is not the answer. What we see in case C is, initially there is some velocity at zero distance, and as the distance is increasing, velocity is going down. It means there is the case, this is the case of retardation which happens in this case. So see, basically this case represents when a ball you throw upward with some velocity, its speed goes on decreasing, will stop at some point of time and then it will return back, right? So for this, what equation we should use? At any instant the velocity is v, x is the height covered, so we'll be using the formula v square equals to u square minus 2gx, right? Where u square is something constant, v is the variable which is changing with x. Now v के power 2 है और x के ऊपर 1 है, so this will give you a parabola, and here it is minus sign, so this will be a downside parabola, which is justifying option C, downside parabola, right? You can put some values on this also to check the result, right? Like x equals to 0 पे v equals to u आ रहा है, जो कि ये वाला पॉइंट रिप्रेजेंट कर रहा है, ठीक है? At some point of time this velocity has to be 0, right? And that will be the maximum height, right? जो कि ये वाला पॉइंट को रिप्रेजेंट कर रहा है. If we see why not D, so simply D is not justifying these observations which are obtained in C, right? Means ये टच ही नहीं कर रहा है, मतलब D जब 0 हो रहा है, so its velocity is infinite. It's saying like this, okay? Similarly, when velocity is going to be 0, its distance is infinite, right? So this does not happen, and there is no case of return in this D option also, okay? So C is the final answer to this question.